what happens if we have a problem like 2 inches plus 3/4 inches? Well, we're familiar with the saying answer should be 2 3/4 inches. So even though we couldn't really give you like 4 inches, like a number like that, we can write that as 2 3/4 inches. In other words, we can sometimes add and write the answer in a way that the units are visible, but the quantity 2 plus 3/4 stays as is and does not have to necessarily be combined together in one number. So anytime you see a quantity like, say, 2x plus 1, you can think of it x plus 1 as a unit, just like you saw inches, centimeters, or apples as units. So in the problem, 2x plus 1 plus 7x plus 1, you can think of 2x plus 1s, 7x plus 1s added to give us 9x plus 1s. And so look at this process. We're treating x plus 1 like a unit. In the next example, then, if you do the same process, you're going to end up with 2 plus a x plus 1s, because x plus 1 is the unit and 2 plus a cannot be added together, so it would just have to remain. So this would be 2 plus a x plus 1s. That's what you're really saying then. Just like 2 3/4 inches. Now it's 2 and a x plus 1s. So in this next one, you'll have to say 9 square root x plus 1s. But if I had a instead of 7, then it would have to be 2 plus a square root x plus 1s. All right, so now let's take a look at practice questions. So there are 5 practice questions here. Pause the video and see what the answers are going to be, and then we'll discuss them. So assuming that you have done the problems, let's continue with the discussion. So for the first one, we have x plus 1 is our unit. So you have 3 of something and 5 of the same thing will give you 8 of the same thing. That will give you 8x plus 1s. 3x plus 1s plus ax plus 1s, same principle, but 3 plus ax plus 1s, we can't really combine the 3 and the a because they are different. Here you're going to get 9 2x plus 1s, 10 2x plus 1s, because 3 plus 7 is going to give you 10 2x plus 1s. But if you have 3 square root 2x plus 1s and 7 square root 2x plus 1s, you will again, square root 2x plus 1 is our unit. Just like here, 2x plus 1 was our unit. And so you'll get 10 of those. Look at the difference between this and this. You have 10 of these and 10 of these. But the square root 2x plus 1 is a different unit than 2x plus 1. For the last one, x is our unit, and so you'll end up with 3 square root 2 plus 5 x's. And 3 square root 2 plus 5, you can't really add those. So you can, that was like the 2 3/4 inches example. Can you see that? So again, go through each one and process the logic behind this addition, because that is going to be the key for everything that's coming after. Everything's going to build on this process of addition. So what do you think we should do if you have these examples? So go ahead and give it your best shot. So you're going to have the units have to be found out first. So here we have a plus b is our unit. And so you have 3 of these plus u of these plus v of these. So you're going to get 3 plus u plus v of those. So instead of adding 2 objects, now we're adding 3 objects. Can you see that? So now let's take so a plus b is the unit here. All right, so now what if I wanted to do this? Can I add 4 centimeters and 3 centimeter squares? Well, no, because this is 4 centimeters, whereas square centimeter, that means you're adding squares. So this is area versus length. You can add area and length together. So you have to add lengths which is the 4 centimeters and the 9 centimeters together, and the 3 square centimeters and 5 square centimeters together. And so you'll end up with 13 centimeters and 8 square centimeters. What about this next one? We can just leave it like this because they're all different units. However, you know that in the standard international units, the SI units, meters, centimeters, kilometers can be converted from one to another since they're all lengths. And how do we convert that? We'll see that in just a second. So we know the facts that 1 kilometer is 1,000 meters or 3 kilometers. So that would be 1 kilometer plus 1 kilometer plus 1 kilometer, which would be 1,000 plus 1,000 plus 1,000 or 3,000 meters. So if you convert all kilometers to meters, you'll end up with 3,000 meters. 1 meter is 100 centimeters, or 2 meters would be 1 meter plus 1 meter, or 200 centimeters, and so on. So let's take a look at what we can do. 3 kilometers we have is 3,000 meters. 200 centimeters is the same as 2 meters. See, now all of these units are in meters, so we can add them together and we'll end up with 3,009 meters. Look very carefully and see what just happened. So we had kilometers, meters, centimeters. So we're converting kilometers to meters and centimeters to meters. We can see that just from this, because 1 meter plus 1 meter, remember 1 meter is 100 centimeters, so 100 plus 100 is 200 centimeters. So 3 kilometers is substituted by 3,000 meters. Remember when we discussed vocabulary terminology, substitute means replace with another, equal, equivalent object. So 3 kilometers and 3,000 meters are equal to each other, so we're replacing one with the other. 200 centimeters is replaced with 2 meters. And then now they're all the same units, and now we can add them together. All right, how about this next one? Do the next one on your own. We'll give you a few moments. We've shown you here how 4 meters is the same as 400 centimeters. So go ahead and do the one on your own. We'll pause for a few seconds. So we're replacing, substituting 400 centimeters in place of 4 meters. And now you can have 3.3 centimeters, 400 centimeters, and 3.3 plus 400 will give you 403.3 centimeters. So we converted some units to another to make these all the same units, and we were able to add them together to make one unit. But if you cannot combine them together, then they have to remain separate like this, like centimeters and square centimeters. All right, so let's see, how can we add two functions together? So let's say I have f of x as this function, g of x is this function. I want to know what is f of x plus g of x. A natural way to add them would be just adding the individual functions together. And so here we want to add like terms together. So since this is polynomial addition that you've learned before, you can add these objects together. And so mathematicians define a new function whose name is f plus g. Normally when you describe functions, you have only one letter or a name as name of the function, but we can also have this notation for a name of the function. And what does that function mean? The f plus g of x function is literally adding the two separate functions together. Remember, any function, when you define it, you also have to define its domain then. Since the x has to make sense in both f and g, the domain of this new function f plus g consists of elements that are common to the domains of f of x and g of x. So the intersections of the two domains of f and g is the domain of the new function f plus g. And you simply are just adding the two functions. So here are some practice problems. See what you can do with it. Let's do the first one together. F plus g of x. So that means you're going to take the first function. Then for g of x, you're going to take g of x function and add them together. The reason we have 6 square root x's is because you have square root x, square root x. So 5 of them, and 1 of them will give you 6 of them. 4 x's and 2 x's will give you 6 x's. So for the next one, you can see how we want to add r of s and s of t. And so you'll end up with, you'll end up with t squared and 5t squared is 6t squared. 3t and 4t will give you 7t, and then plus the 12. All right, you do the next one. H plus f of a. Well, first of all, here we have h of t, and here we have h of a, because a is the input. So we have to compute it first. So if you have f of x, then f of a would be replace x with a's, right? So let's do that. So f of a would be square root a plus 4a, which is right there. What about h of a? H of x is 2x plus 4, so you're going to replace the x's with a's. And then that will be your function right there. And now how do we add those together? Well, you know 2a and 4a are similar, so you're going to add 6a. Square root a, there is no other square root a, so it'll be square root a. No other singleton, so that'll be 4. So here you can see we had an extra step. Since it wasn't the same input, you first had to evaluate with the new input the two components that you wanted and then put them together. And that's how you add functions. So adding functions can have an extra step of evaluating the functions at the input first before you add them together. All right, take a look at these questions, see what you can do.